All right, and with that said, I'm going to go again. I'm switching over to this book right here. This is the Learning Objective-C. I have. It's funny that it's that color because I have a copy of it and it's green. But I think this is a good book. I didn't get this one until May, and if you don't know it, like right now, um, I'm going to have to put in my book orders by March for full. And once they're in there and they're in the system and they get published to banner, it is against the law to change them. You can't do that. You know, maybe I told you this story already a couple years ago. Doug found a book, same publisher, but it was a better book, half the price, but they wouldn't let him change it. Because they said it's some educational law that once it gets published, it has to do with it's out there, so people who are on aid, they start calculating stuff, so you can't change it. Even if you make it cheaper, you can't do it. So, that said, I'm jumping into this. I think this is a good book. I think a combination of this book and the other book that we just started going through, it would be a great book. I like the way this guy writes. I think he's got a nice style. So I want to go over part one here. C, the foundation of Objective-C, more about C variables. We'll jump through those quick. All right, an introduction to object-oriented programming. How many times can we say what an object is? All right, so we won't spend much time on that. But your first Objective-C program, we'll look at that. And again, it's not expected that 100% it totally makes sense right now. All right, 98% or so, that'd be just fine. All right, yeah, at least one person smiled. That's good. All right. All right, couple things. Again, not a lot of code in this book, just so you're aware of it. All right, if you've started looking through it at all, or if you haven't, either way, there's not a lot of code in it. I did mention this to you already, but I want to say, excuse me, want to say it one more time. This book, as it says, concentrates on Objective-C. It won't teach you how to write Cocoa. It won't make you an expert in Xcode. It covers and makes use of just a small part of the framework. All right? And we've talked about this a little bit. You're going to see it as we go on. So there'll be a lot of options that are in there when you start up Xcode, and you'll go, what does that do? And I'll say, try it, because I don't really know, because I haven't tried it. All right? All right. Again, when they talk about what's new in Objective-C, all right, garbage collection, that's kind of, we've already started to sort of get into that. Then they go through what's in every chapter. That's all nice, fine stuff. They talk about ARC, memory management. So they don't really get into it until chapter 16. They don't have a lot of examples in here. It says the exercises. I don't believe that I found these online anyplace either. I could be wrong, but I don't think I did. All right. Again, there's not a lot of code in here, so I'm just jumping into it. All right. So, again, C, the foundation of Objective-C. All right, more on C variables, in an intro to object-oriented programming, etc. I've marked the heck out of my book because there's just a few things in these chapters that I wanted to bring up with you. All right, because my guess is that most of the stuff that's in here, you're already familiar with. All right, so I've gone through this and gone through this and gone through this. All right. Again, they talk about what main is, how to do formatting, comments, variable names, naming conventions, what you're going to find when we get into the Objective-C part. All right, what they do is, again, they use camel casing. All right, we've talked about this before. Classes, so if I have a class that's called tax rate, it'll be capital T, little ax, capital R, little ate. Make sense? If I've got a variable or a method named tax rate, it'll be lowercase tax, uppercase R, lowercase ate. That's pretty much become the de facto standard in here. All right? And they talk about this. What you'll also notice when we start to create variables, and I've mentioned this the other day, but just kind of in passing, quite often we'll start them with an underscore. We'll get into why that's the case already on Thursday. Did your Xcode ever finish loading? Okay. All right, they talk about the different integer types, floating point, etc. I will mention, talking about bool, there is a Boolean type. I think I said this the other day in Objective-C. It's capital B-O-O-L, and its only two permissible values are yes and no. All right, their pointer thing is no better, no worse than what we talked about before. Again, if you think, Kim asked the question before. I think this, I'm kind of paraphrasing what you said, but no, we're going to slow it way down. I plan on starting back on this book, this one right here, on Thursday. All right, and we're going to be going over chapter by chapter what's in this book. And I don't mean that we're going to that's all we're going to do for the next week. No, we'll do other stuff too. But we're going to cover everything in here that's in the beginning Objective-C section, which is chapters 13 through 32, and then we'll do the advanced Objective-C, which is 33 through 37. All right, we will do all that. We will cover, and in a lot, not nearly the speed in which we covered this mini review of C today. All right. I'm looking in here. I don't think I even had much of anything that was even done. I mentioned the naming conventions to you already. I want to make sure I said that. All right, pointers we've already hit on, so I don't have to really go through that again. I don't know if there was even anything else I wanted to discuss in this chapter. Like I said, it wasn't going to take a whole heck of a lot of time to go through this until we get to that last chapter that's in there. All right. Now I saw this. I'm going to move up all the way to page 38 in here. And I want to tell you this. You don't have to look, but if you listen, I mentioned this the first day of class, but I'm going to say it again. When I'm at home and I've got my MacBook, not mine, the one that the school lets me use, and I've got Xcode running, and I try to put in the programs from chapters 31 or 32, all right, or whatever, what I'm getting is that I have, there's some kind of it's not even a linkage problem. It doesn't recognize my provisioning profile. Now, Bob, you've done some work in this. Did you ever have any problem when you went over and started to do anything GUI? Well, but the reason what I'm telling you is it's giving me an error when I start to do the build. It's telling me it can't go on, but I go on anyway. Okay, I key the whole program in, I get it to compile, but when I run, it doesn't show me any output. It just shows me a blank emulator. That's it. It's just blank. I've Googled it up the wazoo, and I found people who say they have similar errors, but the stuff, their background is nothing like what I'm doing. So I'm still looking for that. So we'll be able to get through every program in here, but we'll have problems until I can figure that out in chapters 31 and 32. Now, I told Terry about this. He's our IT guy, the virtualization engineer, and he's like, oh, that sounds cool. So he wants to look at it. All right. Unfortunately, he's on another project, and he'll be on it for another week or two. So hopefully he'll be able to look at it fairly quickly. All right. Again, if you want more, I actually like the way that they explain the memory layout in an Objective-C program right here, because then they talk about the stack, they talk about the heap, the data segment, and the text segment. And in particular, they mention what all these things are here on the next page, so on page 42. As it says, going from the bottom to the top, the bottom section contains all of the program's executable code and read-only data. Going up to the next section, it contains read-write data, including global variables. Then you've got the heap, which contains the blocks of memory, which we just talked about before. Then we've got the stack, which is in there for calling functions. So it's a pretty nice, it's limited, but it's a pretty nice explanation. Then again, they talk, and I mentioned this to you before, that this little mini snippet of a program right here, you notice that it says float average. Since that variable is defined inside of a function, it's as though we wrote auto in front of it. And you can, but that's considered redundant to do. All right. External variables, again, are typically written outside of any function, and quite often what you're going to find is they'll have extern in front of them if you're writing a program. You know, the programs that I did, again, I'm sure they were very different than the ones you did, but a lot of times we'd be using variables and there would literally be hundreds of us using the same variables. All right, and sometimes tracking down where the original variable was actually created was really a pain in the butt. We didn't have nearly the sophistication in editors that we have now. All right, I mean, you can only do so much with Emacs and VI. All right, so there's auto, there's the extern, then there's static, and we talked about what static means before, that if you take a function variable name and you make it static, it retains its value throughout function calls, and it mentions all that stuff in here. And then you've got register, which you may or may not have ever heard of before. All right, what a register variable is, this is my take on it. Again, maybe not everybody in here would agree exactly the way that I put it, but first of all, there's a limited number of register variables that are always available. All right, and how many? It depends on the system, the requirements, etc. Okay, but what you can do is do this. Typically, when you ask for a variable to be a register variable, you equate it with some kind of a counter. All right, and the idea with a register variable is they're supposed to be faster variables internally. They're faster than a regular variable. Now, that's the good news. The bad news is the system can decide, as it says, the compiler is not obligated to honor the hint. So you can put it in there, and either if there's not a register variable available or for some reason you don't get it, it becomes auto automatically. So the idea is they're supposed to be faster. Okay. All right, const, as it says, the const keyword tells the compiler that a variable should be considered a constant. Well, we've already looked at stuff like this. So when you declare the variable with const, you've got to give it a value. And if you attempt then to put the same variable name on the left-hand side of an equal sign, you'll get an error message. Is that really that important? No, but the next little section here, when const is used in pointer variables, the order is important. As it says, the declaration should be read from left to right. The following example declares that PTR is a constant pointer to an integer. All right, constant pointer to an int. So, notice what it says. That's okay. That's not okay. So what it's saying is you cannot modify it to point to a different variable. You can use it to change the value, but you can't use it to, once it's pointing to one thing, you can't make it point to something else. All right. However, putting the const in front of the rest of the declaration has a different meaning. So now notice what you have. Now we've got const int. So there's the other one. Star const. And here we've got const int star. So it is at the beginning or is it at the end? All right. So now it says, okay, A has not been declared as a constant, but this is okay, but this is not okay. So in the first case, you can change the value, but not what it's pointing to. And in the second case, you cannot change its value, but you can change what it's pointing to. You say, well, that's confusing as hell. Then try to limit your usage of them. All right. All right. As it says, the volatile keyword declares that a variable's contents may be changed by something other than the program's main thread. You probably realize this if you think about it, but as you're running a program, you're running the program, whether it's Windows or Mac, you're running the program underneath the auspice of an operating system. And there's all sorts of things that can be happening in the operating system while you're running your program. Sometimes you may want your system to respond not to your program, but to something that's happening or externally from the operating system or whatever, and you can use volatile to do that. Now that's not a great explanation, but you're probably not going to use that anyway. All right, then they talk about scope. They get into dynamic allocation. We've hit on all this stuff before, a little bit on malloc, etc., so that's not really new either. So see how fast that was? I'm jumping right into an introduction to object-oriented programming. And again, this will be even shorter than the other ones were because all I want to mention here is just some terminology. This is all terminology that by now everyone in here should have heard about already. Okay? Again, Objective-C is an example of an object-oriented language. It's very interesting because the first-year people now who have me for the 142 class were doing C# in there, and then they've got me for C# and for Java. And there's been one person so far who said these languages are almost identical. And that's true, yet it's not true. Syntactically, they're very close. All right? Is what? No, but what I'm getting to is, again, C# and Java are close, and I've told people before that in many ways Java is, or I'm sorry, C# is Microsoft's attempt at writing Java. All right, and there was actually an article online, I wish I'd have kept it, where somebody wrote back, some C# engineer saying that they were offended by that, because sometimes, as the saying goes, the truth hurts. All right. But words that you should know by now. You should know what encapsulation and information hiding are. The idea, because you used them all the time. You used them all last semester. There were a lot of times when you'd say import java.util.whatever. And what were you doing? You were using information that was made available to you in other Java packages. Did you know how they worked? You had to know how to call them. Like when we did the string stuff and you had to manipulate strings. Probably you don't know internally how the code that Java wrote to do that. Usually you can't even see it anyway. All right? So it's encapsulated or hidden from you. All right? And in this language, too, a lot of the stuff that you do will be encapsulated or hidden from you. All right? By now, hopefully inheritance makes sense. In this language, you'll be using a colon to show inheritance. We'll get into that in the next class. And much of the stuff that you do, unlike Java, where you said something like public class hello. You never would say extends object. I told you could say that, but it was redundant. Here you have to always say what the class extends, even if it's NS object. All right, you have to always say that. So we'll get into that. Polymorphism. This is, again, all right, this is something that you should understand. And what they're getting to is right here, if, for example, it won't let me highlight that, but if the system let me highlight that picture right there, and I right mouse clicked on the picture, and I click print, the system would know to print it, but it would know to print the picture. As opposed to me highlighting some text and click it and click print and print text. So in other words, if you imagine that all my graphics were in one class and all my text were in another class, I could give both of them a print message, and depending on the type of class they were, they would know how to handle it. They would know how to print. You know, the classic case of this is you make a class called mammal. And up at the top of mammal, you create a abstract method that's called speak. And then you create a dog under that and a cat under that, etc. And when the dog speaks, the dog knows to go woof, woof, bow, wow, whatever. And the cat knows to purr. They're both responding to the same method, but they know how to respond based on the type of class they are. And if you get that, that's what polymorphism is. I love that section right there. What is the point of an object-oriented language? All right. You argue and say, well, I got to take it because if I don't, I won't get my degree. All right. Well, I guess that's one point. But the idea, again, is it's a modeling language, and it's designed for code reuse. Okay. So here's new. An introduction into Objective-C. So let's get into this. All right. Again, we talked about this, that it's the object-oriented extension to C, that it's a superset of C, etc. So this is the kind of stuff that we're going to be doing. All right. When you define a class in Objective-C, it has two parts. It has an interface section and an implementation section. The interface section is the .h file. The implementation section is the .m file. So the interface section will look something like this. Literally, it starts with @interface, it ends with @end. You've got the name of your class, colon, and what that class extends. Then inside of here, as it says, in the curlies, you put any instance variables that you have inside of there. Then outside of the curlies, but before the word end, that's where you declare your methods. Notice, declare your methods, not where you write your methods. You're doing declarations here. And whatever this interface file is, so if I've got a class that's called Hello World, that's the name of my class, I'll have both a hello world.h and a hello world.m. And the hello world.m must import, we don't include anymore, but it must import the hello world.h. Otherwise it won't work. I mean, these are just things you're going to have to understand as we start walking through this stuff. Again, if you like their words better, then go and look at what they have. I'm tired of reading the people. So here's an example of an interface. So what does this say? All right, we've got one instance variable here called total. We've got 3 instance methods. If they're instance methods, again, they start with a minus sign. If they're class methods, they start with a plus sign. These are all instance methods. The first one returns nothing. You immediately follow it by the return type in parentheses. The second one returns an int. The third one returns nothing. You'll notice that this one right here is the same name as this one right here. It's totally legit in this language because what is that? That's a getter. All right? So that the getter can have the same name as the variable that's being gotten. Wait, that didn't sound right. So that's why typically when you write this, see if it lets me copy here. Yeah. Typically when you write this like this, you don't say int total. Usually you say int underscore total. That's not a requirement. Half the books you find out there will not show that, and half the books you find out there will show that. All right? So again, I'm just showing it to you this way. So this is an interface. What we're doing is declaring and declaring. We're not defining anything in here. We're not implementing it. That'll be in the .m file that you'll see in a minute. So this says, again, right here, this. All right? That says it's an integer variable, and literally its name is underscore total. If we don't want to put in the underscore, again, we don't have to. And again, you'll notice that the name of the variable and the name of the getter can be totally the same name. You can't do that in most other languages. That would be get total, all right, as an example. All right. Again, it's all explained in here. They talk about the leading hyphen as opposed to a plus sign. So here's an example of the implementation. Okay, it's the .m file. As I mentioned, the first thing you're doing is you're importing the header that we just created. All right. And then everything that's in there, in fact, the recommendation is that what you do when you're writing the .m file is you copy this stuff, you come over to your .m file, so imagine this was my .m file, and you immediately paste that in. And then when you paste it in, just remove all the semicolons. And then you come in here and start actually writing the functions. Okay? Well, that was neat. It just gave me a noise in my ear there. All right. Now you should be able, hopefully at least, to look at this code, and I'm hoping at least, like I said, that it makes sense. Notice that the other one, the .h file, started with @interface. This starts with @implementation, and it again ends with @end. And what we've done in here is we're taking those 3 methods, there's the first one, there's the second one, and there's the third one down here, and we're implementing them. So what is this? All right, we're not returning anything, but this is actually the name of this, again, is called add to total : That's the name of it. It's not add to total, it's add to total : It's expecting you to pass in an integer value that's referred to as amount. And what we're doing is we're taking and we're adding amount to our total. No one's asked, but just so you know, you can also use the plus equal, the shortcut. They could have just said their total plus equal amount. That would have worked fine. All right. Again, there's our getter. Notice that's all we're doing is returning the total. And there's our zeroing out total right there. Again, they're all explained there if you don't like my explanation. Okay? All right. Inheritance, as I mentioned to you before, in the interface, you have to say what you are inheriting from. So if I made another class that was inheriting from accumulator, so if I wanted to specialize accumulator, I could have their at interface special accumulator colon accumulator type of an idea. And there's no level again as far as the number of levels that you can work on this. All right. All right. Class names as types. I'll let you read that yourselves, but the key thing to realize in here is basically everything is an object. Even classes themselves are objects in this language. Everything in the language. Everything is an object. All right. So how do we work with this stuff? You've already seen a little of this. There's the syntax. You use brackets, and notice when it says message, basically that's the method that you're going to call. And the receiver, that's what you want to have, the object that you want to execute that method. All right, we're used to doing things where we use a dot syntax. This is the syntax that's typically used, although at least at times you can also use the dot syntax, which makes it even more confusing. So notice what we're doing right here. You may or may not remember this, but add to total colon, that doesn't return anything. So what we're doing is we've created an accumulator someplace that has a value in it. So what we're saying is to that accumulator, add 137. Does that make sense? All right. And here, total does return a value. So that's going to return the current value of total. So the idea is current total will now hold 137. All right. All right. I don't like what they talked about there. It was very confusing. All right. We'll finish this and we'll just call it a period. This class, objects, and object creation here. You're going to do things like this. This is maybe the most important part of this chapter. Is the bottom of page 64 and then going on. All right. And that is this. You're going to write things that are like this. And when you read this, you've got to read it from the inside out. So in other words, what you're saying is we want the accumulator object to call the alloc method. All right. So as it says, an alloc method is sent to a class object for the accumulator class. Okay. Then once that's done, that allocates the memory, and as it says, it returns a pointer to the uninitialized object. Then that together becomes what you send when you call the init method. As it says, init is an instance method that accumulator inherits from NS object. Typically what that's going to do is you do that, for lack of better words, in lieu of calling like a constructor. What that'll usually do is for like a numeric variable, unless you tell it otherwise, it'll just set it to 0. If it's a string, it'll set it to the empty set, etc. Right. The other stuff that's discussed in here, this is with memory management, this is what you have to do if you're not using ARC that we talked about before. So in other words, if you have to manually keep track of every time you allocate something, all right, what happens is when you allocate something, you may or may not own it. If it's basically, if it's something that you created, you own it. But if it's something that somebody else created that you grab, you don't own it. Why is that important? If you own it, you're responsible when it's all done. If you're not using automatic reference counting, you're responsible for making sure that its counter is set to 0. In other words, that it goes away, that it frees up the memory. But if somebody else owns the object and you just want to borrow it or whatever, then it may go away automatically unless you say, I want to retain that object. Once you retain it, then it's not that it becomes yours, but you have a piece of it, for lack of better words. But then for every retain you put in, you've got to put in a release. Okay? That may or may not make any sense, but you're going to see it as we go on in here. The last stuff that's in here, on the last few pages, it's very complex. I'm not going to throw anything by you. They give you some stuff about naming rules. All right. And some of this I've already gone over with you for caseness, etc. Again, Apple considers method names that begin with an underscore to be reserved for internal Apple use. That's a method name. That's totally legit for variable names. All right, you're going to see that as we go on. Compiler directives, you've already seen some. They start with the @ sign, @ interface, @ implementation, @ end we've already seen. Here's a different one. That's how you create a string, an NS string. You need the @ sign at the beginning. Okay. Also, anytime you're printing out, one thing that's nice about this is anytime you're printing out an object, it doesn't matter. The system doesn't care if it's a string object, if it's a dictionary object, if it's a set object, if it's something else. The system doesn't care. But what you're going to use when you print that out is %@ sign to print that out. All right, that's how you print out objects. You also have something special in this language. It's called ID. All right, some people say, "Oh, that's like a void pointer in C." It's not exactly the same thing. It's something that it says pointer to an object, but to keep it simple, the biggest thing that you get from Objective-C that you don't exactly get in regular C is you get a lot more dynamism. That at runtime you can figure out exactly what you want to send to things. All right, that's what you really get in this language. If you make something of type ID, then what you're telling it is at runtime I'll let you know the kind of object I'm referring to. And I can call it once with this object, and I can call it again with another object. Bool I already mentioned to you. I don't want to go over cell and imp right now. They're fairly complex, and we're going to get into them in later chapters. I already mentioned to you, again, classes themselves are objects. All right. And they basically finished the chapter off by talking about some of the different data types that are in here. All right. And you can see them on pages 71 and 72. We're going to get into a lot of these. One of the most important ones right away is going to be NSLog. So what I want to do on Thursday, didn't get quite as far as I wanted to, but I want to go over this. And ideally by that time, we'll all be able to write this together. All right. Now, that'll be the first day I'm going to actually bring my machine in here, but again, I'm not going to be able to show it up there. Because if I show it up there, Sean can do that. He says then you're going to lose your link to Camtasia. And I don't want to do that to the people who are in this class, but are not coming on a regular basis. All right. So we'll pick it up there. In this book, we're going to go over chapter 4, and then we're going to jump back into the other book. So that's what we'll do on Thursday. All right. That's all I got.